Today we are working on topic 3, solving literal equations. Our I can statement is I can solve linear equations for one variable. So, as I mentioned, today we're focusing on literal equations. And a literal equation is an equation that shows a relationship between two or more variables. So to be a literal equation, and the most common ones are ones that look like formulas, you have two or more variables. So for this first type of problem, they just ask you if it is an example of a literal equation and for you to circle it. So 2x plus 3x equals 10. There are two terms with variables, but they're like terms. They have the same variable. So no, that's not a literal equation. We can actually solve it and get an answer for x. Now on this one, x minus 3y equals 4, that one is a literal equation. It has a y and an x in it. Just on its own, we can't solve anything for a number value. We would need more than one equation for that. So is that a literal equation? Yes, it is. It's got more than one variable. The most common literal equations are ones like this, which are formulas. And they have lots of different letters that stand for different things in your situation. This one happens to be a surface area formula. So this is 2 times pi times radius times height. That's basically the ends of a cylinder here. The rectangle on a cylinder. So this is a literal equation because we have variables s, r, and h. So yes, that is a literal equation. If I want to solve for a letter, I need some more information about the other variables. All right, so it says the steps for solving a literal equation for a specified variable are exactly the same as solving an equation to find the value of the variable. However, there will not be a numerical answer like x equals 2. So we're doing the same steps, which are order of operations backwards, doing inverse operations to get whatever variable we need. So first one, solve for p. I equals PRT. This is one that you will see later in the year when we get to simple interest. It's the simple interest formula. And we're solving for p. So PRT means p times r times t. To cancel out multiplication, we use division. So we need to divide both sides by r and t to get rid of the r and the t. R divided by r is 1. T divided by t is 1. So that leaves my equation to equal p. And then over here, my answer is going to be I divided by RT. I can't actually do that division. There's nothing to simplify. That's just what my answer is. So if I knew my numbers, then I could take my interest number and divide by my rate and time number, and then I would get my answer for my principal. All right, let's look at this next one. This is a formula for the perimeter of a rectangle. They want us to solve for W, which is the width. So perimeter equals 2 times W plus 2 times L. Now it does look like a 21 there. I'm going to just put that as a capital L. But I know since that's a perimeter formula, I know that's supposed to be an L. Okay, so I need to solve for W. I have two steps here. I have a multiplication with the W. I have an addition with the W. So I start addition on the side that has the W. If this was just, call it 10 equals 2W plus 2 without a letter there. The first thing I do is get rid of that plus 2. I have to get rid of the addition and subtraction first. So I have to get rid of the 2, but I need to get rid of the 2L. So I'm going to subtract 2L from both sides of my equation. Just like we did when we had ones with variables on both sides. So on this side I have 2W, 2L minus 2L is 0. P minus 2L, I can't actually do P minus 2L, they're not like terms, so I just write P minus 2L. Now I have multiplication, 2 times W, so I have to get rid of that with division. Here's the tricky thing, when we're dividing by a number, we need to make sure that everything is divided by that number. Now I can write it as one big division problem like I did here if nothing's going to simplify. But looking at this, I can tell that things are going to simplify because I've got a number or a coefficient in front of the L. So I'm going to write the division separately. P divided by 2, negative 2L divided by 2, and then my 2W divided by 2. P divided by 2, I can keep as P divided by 2, or I could write it as 1/2 P. I think I'll just write it as P over 2. Minus, but here I have 2 divided by 2, that cancels out. 2L divided by 2 is 1L. So P divided by 2 minus L equals W. That is my literal equation solved for W. All right, number 6, solve for R. So I have V equals pi times radius squared times height. This is the volume formula for a cylinder. Okay, so I need to solve for R. This is tricky because R is squared, so it's going to give me an extra little step in there to do. Pi times radius squared times height. All of those variables next to each other mean multiplication. If I have to get rid of it, I have to get rid of it with division. So I'm going to divide this whole thing by pi and h, because those are the things I want to move. Pi, whoops, helps if I write what I'm saying. Okay, let's try that again. Pi times h. Pi divided by pi is 1. H divided by h is 1. I'm left with r squared. So I have volume divided by pi times height equals radius squared. Now, in an equation, and we haven't seen equations like this yet, but we will be looking at them more as we get through the year. If I have an exponent, this one's a squared, then the square root is going to help me get rid of that exponent of 2. Square root symbol is a radical. It kind of looks like a check mark combined with a division sign. That's called the square root. And doing the square root on both sides cancels out the square. So the square and the square root cancel out and leave r. And over here, there's nothing I can simplify, so I just have to write it as volume divided by pi times height, and then I've got the square root of that one. All right, let's look at some more problems. So why is this helpful as a skill? Using formulas, which I mentioned before, it helps to manipulate formulas to make them easier to use. And then useful when you're discussing special forms of equation. As you move into algebra, you'll be seeing more equations that are similar to these. Okay, so here, solve for y. I have 2x plus 3y equals negative 6. Okay, so 3 is being multiplied times y. I have a 2x over here that I need to move. We're going to get rid of the addition and subtraction first. So this is a positive 2x that's getting added, which means we need to subtract 2x from each side. 2x minus 2x is 0, so it leaves me with 3y. And then I have negative 6 minus 2x. I can't actually subtract them. Okay, and then I have this times 3 I have to get rid of, and I get rid of that by dividing everything by 3. And like I said on that last slide, when we're dividing and we're dividing with a number, we're going to write that number under each thing. 3 divided by 3 is 1, so I'm left with 1y. All right, negative 6 divided by 3 is negative 2. Minus. Now here I have 2x divided by 3, and 2 doesn't divide evenly by 3. So I'm going to think about it as a fraction, and I'm going to pull it out front like a fraction. 2 divided by 3 as a fraction, 2/3. So I'm going to write 2/3 minus 2/3 x. All right, next one, solve for y. I have a negative y, a minus y. All right, so I have x minus y equals 4. I've got to get rid of this x. Now this minus goes with the y. If it helps you, you can do boom, change to addition, boom, change the sign. That is a negative y. I have a positive x. I need to get rid of it by subtracting x from both sides. X minus x is 0. I'm left with a negative y equals 4 minus x. Okay, then I need to get rid of that negative. It's like a -1 being multiplied. So I'm going to divide everything by -1. All right, -y divided by -1 is a positive y. 4 divided by -1 is -4. Negative x, because I could do boom, boom. Negative x divided by -1 is a positive 1. So I have y equals -4 plus x. And then our last one, a times x plus b times y equals c. That's a standard form equation formula. We're going to solve it for y. So we've got to get rid of this ax part. That's like a number, a times x. It's addition. We've got to get rid of it by subtracting. So we're going to subtract ax on both sides. So I have by equals c minus ax. To get rid of the b, that's multiplication, I've got to divide by b. This time, because I'm not dividing by a number, I'm dividing by a variable, I'm just going to write it underneath the whole thing because I can't simplify it. B divided by b is 1, so I'm left with y equals c minus a times x divided by b. All right, let's take a look at this next one. So solve for b to the, with the subscript 1, b1. So this is our area formula for a trapezoid. We're going to solve for the first base. So 1/2 times the sum base 1 plus base 2 equals height. Normal order of operations would have us do the parentheses first. So because we're doing opposite operations, we're going to get rid of the parentheses last. We're going to get rid of the times 1/2 and the times height. All right. I'm going to actually do them one at a time. I'm going to move the height first. I'll show you why in a minute. All right, so if I divide both sides by height, height divided by height equals 1. So that cancels out. And then I have area divided by height. A divided by h equals 1/2 times b1 plus b2. Okay, now I'm going to get rid of the times 1/2. If you think back to when we did the fraction equations, to get rid of the times 1/2, we would divide by 1/2. But dividing by 1/2, if I do keep change flip, is like timesing by 2. If I do 1/2 times 2, it equals 1, and they cancel out. So I'm actually going to multiply by 2 on this side as well. So now I have 2 times a divided by height equals base 1 plus base 2. My parentheses I don't need anymore because I've gotten rid of all the multiplication there. All right, and so now my last step, I've got a the second base, that b2, that I need to move so that base 1's by itself. It's addition, so I've got to move it by subtracting. So my final answer is going to be 2a divided by h minus b2 equals b1. All right, let's look at this next one. Solve for r. This is our circumference formula. Circumference equals 2 times pi times radius. This is multiplication, 2 times pi. I've got to solve for the radius. Because it's multiplication, we cancel it out with division. All right, c divided by 2 pi equals radius. All right, number 12, solve for c. I've got the Fahrenheit to Celsius conversion formula here. That's what this is. We need to solve it for c. Okay, so let's go ahead and try this. We've got to get rid of addition and subtraction first. That means I'm getting rid of that plus 32, and I get rid of it by subtracting it from both sides, minus 32. I can't actually do f minus 32 because they are not like terms, so I just have to write it out. F minus 32 equals 9/5 c. Now we're going to multiply by the reciprocal of 9/5 to cancel it out. reciprocal of 9/5 is 5/9. So I'm going to multiply by 5/9 here, and here I need to multiply by 5/9. And since I need to multiply the whole thing by 5/9, I'm just going to put the parentheses around that part and put the 5/9 in the front. 9s cancel out, 5s cancel out. I'm left with C. 5/9 times the quantity F minus 32 is the formula I would have to use if I want to solve for a Celsius temperature. All right, let's take a look at number 13. The formula for volume of a rectangular prism is volume equals length times width times height. A, solve for W, and then B, what is the width of a rectangular prism with a volume of 79 and 400 centimeters, a length of 5 2/10 centimeters, and a height of 4 centimeters. So they're kind of giving you a reason for doing our literal equation and solving for W, because we're going to have to solve for width in our story problem. All right, solve for W. I'm going to start just by writing my formula. Volume equals length times width times height. This is all multiplication, so we've got to divide. I'm going to divide by length and height. All right, lengths cancel out, heights cancel out, so I'm left with volume divided by length times height equals width. All right, so now I need to actually put my numbers in and solve for width. So I have a volume of 79 and 400 divided by, I have a length of 5 2/10 and a height of 4. All right, and then that all together is going to equal my width. So I took the numbers here, I plugged them into my formula, and now I need to do my calculations. All right, so the first thing I need to do is any calculations that are on the same side of the fraction symbol, the division bar, here together. So I'm going to do this multiplication 5 2/10 times 4. I'm going to do it off to the side. 5 2/10 times 4. 2 times 4 is 8. 4 times 5 is 20. 1 decimal in the problem, 1 decimal in the answer. All right, and so now I have 79 and 400 divided by 20 and 8/10 equals W. I need a little more space here. Okay, so I've got a decimal in my divisor, my second number, so I need to move my decimal over one place on both. So now I have 790 and 4/10 divided by 208. So I'm going to need to do some long division off to the side. Those are pretty big numbers. Okay, let's see. 790 and 4/10 divided by 208. Okay, so let's think about it. So 208 does not go into 7, does not go into 9, does go into 790. Let's think about this as just 200 for a minute. If this was 200, it would go in 3 times, because that would be 600. And if it went in 4 times, it would be 800, which is too big. So I know it's going to be 3 times. And now I need to do 3 times 208. The 3 times 8 part is going to be 24, and then the 3 times 200 part is going to be 600, so I've got 624. All right, let's see. I'm going to need to do some borrowing here. Make this a 10. 10 minus 4 is 6. 8 minus 2 is 6. 7 minus 6 is 1. As always, if you do your subtraction on long division and then you get a remainder that's bigger than what you were dividing by, that's your sign that something's wrong. Okay, bringing that decimal up, bringing my 4 down. Okay, so I'm going to estimate again with pretending this is 200. So if this was 200 going into 1600. That would be 8 times. So 208 into 1664 is going to go in 8 times. It actually is going to go in evenly. Okay, so my width is 3 8/10 centimeters. All right, let's look at our key idea here. So temperature conversion, we saw this equation as the answer for one that we did on the other page. Now we're going to work backwards to solve it for Fahrenheit. So I'm starting just by writing it out. C equals 5/9 times F minus 32. Now, I could do distributive, but I'm actually not going to. Normally I would do, in an order of operations problem, I do parentheses first and then I do the multiplication. So I'm going to do the opposite. I'm going to get rid of the multiplication first. So I need to multiply by the reciprocal. That's going to be 9/5. I'm going to do times 9/5 over here. The 5's cancel out, the 9's cancel out. So I'm left with F minus 32 equals 9/5 C. Then I've got to get rid of that minus 32. I do that by adding 32. Can't actually add 32 to 9/5 C since they're not like terms, so I just write it out. 9/5 C plus 32 equals F. All right, let's look at this next one. So which has the greater temperature? We have the sun that has 11,000 degrees Fahrenheit. We have lightning that is 30,000 degrees Celsius. So what we need to do is change either our Celsius to Fahrenheit or our Fahrenheit to Celsius using the formula on the last slide, this one right here. And then we'll compare it. So you can pick which one you want to use. Go ahead and pause the video and try this on your own. Okay, so let's see. I think I am going to use, I will use this one that we just solved. So my Fahrenheit equals 9/5 C plus 32. Okay, let me double check that I copied that correctly. Yes, I did. Okay, so we're going to put the Celsius answer in. We're going to make it into Fahrenheit. So 9/5 times 30,000. Since it's fraction multiplication, I'm going to make it over 1. Plus 32. I love to cross cancel when I have big numbers, so I'm going to go ahead and do that. 5 divided by 5 is 1. 30,000 divided by 5 would be 6,000. So now I have 9 times 6,000. 9 times 6 is 54. So 9 times 6,000 would be 54,000 plus 32. So my Fahrenheit is 54,032 degrees Fahrenheit. Okay, so that is my answer for what the lightning is. So which one has the greater temperature? Well, this is 54,032 degrees Fahrenheit. This is 11,000 degrees Fahrenheit. So lightning has the greater temperature. All right, and our last one, it says room temperature is considered to be 70 degrees Fahrenheit. Suppose the temperature is 23 degrees Celsius. Is this greater than or less than room temperature? So again, we need to pick one of those to convert. Go ahead and pause the video and try this on your own. Okay, let's check our answer. So we're going to use the same formula we did in the last problem. Fahrenheit equals 9/5 C plus 32. Let's double check that formula. Yep, 9/5 C plus 32. Okay, so I'm going to take my Celsius temperature. I'm going to put it in for Celsius here. So F equals 9/5 times 23 over 1 plus 32. This time I can't cross cancel anything, so I'm going to have to multiply straight across. I'm going to need some space to do that work over here. So 23 times 9, 9 times 3 is 27. 9 times 2 is 18 plus 2 is 207. Okay, so Fahrenheit equals 207 over 5 times 1 is 5 plus 32. Going to need to make that improper fraction into a mixed number. Numbers are kind of big, so I'm going to do it off to the side. Let's see, 5 goes into 24 times. It's 0, and then I need to bring down that 7. 5 goes into 7 one time. 2 is a remainder. So this as a mixed number is 41 and 2/5. Goes in 41 times with 2 as a remainder. Plus 32. And let's see, 41 plus 32 would be 73. And then of course I've got the 2/5. Degrees Fahrenheit, that's what the 23 degrees is. So is it greater than or less than 70 degrees? It's going to be greater than.